So today the main intention of this speech is to give you an overview of engineering and process industry. So basically we'll be talking about I'll give an introduction, small introduction, and we'll set the context, and then we'll try to understand what a process industry is, and then how we'll talk about how engineering design is implemented in process industry. So just to make clear before we proceed further, this presentation is not intended to give you any details about a process industry like oil and gas or refinery. So we will be focusing on the engineering part of a process industry. Okay, so what are the different areas and disciplines involved in a process industry? So this slide gives you the various, the broad spectrum of engineering and how broad spectrum of its application in process industry. So if you see on the left-hand side, you see various disciplines involved like mechanical, chemical, instrumentation, electrical, health and safety, civil and structural, telecommunication. Many disciplines get involved in, and later on, recent development is you are getting to see computer science and data science, machine learning also coming into process industries. It is still early days, but then still it is coming. And then in terms of the areas, if you see a process initially when the application of engineering starts right from the concept stage. So when you design, you need engineers. When you construct, you need engineers. When you commission, you need engineers. Operation, you need engineers. Maintenance, manufacturing, marketing, business development. Like for example, engineering is required for business development. When you are doing the marketing, you want to give solutions in terms of engineering to the customers. So you need engineers there as well. Vendor engineering, procurement, inspection. I have listed some. There are many. Like for example, there are metallurgy discipline is there, quality control is there. So there are so many areas. But just to give you a brief, that there are various areas involved, and the spectrum is large. Okay. Now, what is engineering basically? Like for example, normally what we say is the engineering is like if you want to lift, let us say, lift a 2 kg weight. Will I use a thread? No, because it will break. Will I use a wire rope? No, because it is too big to lift a 2 kg weight. I need a small, simple rope is required to lift a 2 kg weight. Basically, engineering is basically getting the right design for the purpose of the application. So I have just tried to give the whole concept, because the theory, we have theory, like I will say in engineering, we have a theory, concept and practical. So theory and calculations, what is it? Whatever you have learned in engineering in the 4-year course, mostly the focus is on theory. So you have learned a lot of theories, lot of calculations. That means you have the tools with you. Like for example, I will say chisel is like a tool. So I will relate a theory to a chisel. Like you can have all sophisticated tools in the world. Like you can have drilling machine, you can have multimeters, so many tools you can have. So similarly, all of whatever you have done, the calculations and everything is like a tool for you. But having tool is not enough. You need to know how and when to use the tools. Like for example, when you are having chisel in your cupboard doesn't help you at all. You need to use it, and you need to know when to use it. You cannot just like that for the sake of it use it. Okay, so removing part of a wood is what chisel can do. So when you know that, that means you know the concept of chisel. Okay, so you know when to use it, and you can know how to do it. But then even that is not enough. Doing some chiseling on a wood is not enough to get the application. So you need to know what is the practical application and how the combination of these tools and the usage of those tools can build a item. Okay, so that is practical application. Like you can use tools to build a table. and various tools like chisel can be one of them. You can have cutting machine, you can have sanding machine, you can have router, but you finally end result is stable. So similarly, what we say is engineering is a combination of theory, concept, and its practical use. So the good thing is while you complete the engineering, you are equipped with the tools. But when you come to the outside world, you will understand the practical applications, and that time you already know the concepts, but you need to relate those concepts to the practical. So that is the whole point of this slide. So you need to know. So you may not get when you come out of engineering, I have seen many students feeling they're not getting the feel of practical application. They get lost. They get a feeling of loss because there is some minor links missing. It is not that you're not equipped, because you are still equipped with your tools, theories, calculations, whatever you learned in your courses. That is the strength you have. You already have a good strength with you. You just have to relate that to the practical applications and remember your old concepts and relate everything together to get the big picture. So that is the purpose of this slide, to put you on the context. Okay. So as I told before, we are not trying to explain any particular process. So what do you think? Is it simple?
Yes, it is simple.
Okay, good. Okay. But then I say, is it really simple? If I am alone in a house and I want just to make tea every day, what all things I need? I need first inventory storage. I need bottle for water, seal container for tea powder, seal container for sugar, bottle for milk, cylinder for LPG. I need consumables. Water is a consumable, tea powder, sugar, milk, fuel LPG, dishwashing soap. Okay, and then I need various equipments, like I need regulator for gas, hose for a gas stove I need, gas lighter for ignition, fridge for storing milk, shelf for storing ingredients, cooking vessel, measuring cups and spoons, kitchen pincers, what you call puckered, strainer, tea jars, serving cups, spoon for mixing, scrub for cleaning. Okay, and then there is a method. You all know the method. So you have to take a clean vessel, boil the water, and then make a tea, and then serve in tea cups. There are various steps involved. And then you have maintenance. Okay, like you have to clean the vessel, cup, and strainer after every session. So that is part of the maintenance. Then you have the service. You have to service the gas stove every 6 months. Okay, and you have refrigerator for the storing milk. So you have to inspect and clean it every month. So this is like a process. When I document the simple act of tea making, it looks so complicated. And who doesn't know tea making, suppose sees this document, they will say it's some complicated step is going on. Right? Okay. So what we say is it really simple? Even simple processes may look complicated when documented in detail. So that is what happens when you go to a practical industry and you see any design documents, you'll be initially overwhelmed, because even the simplest process, when we document it, it looks so complicated. There are so many aspects to a simple act, and that is what happens in a process industry. And there are many supporting functions are required to achieve the main process. Main process may be simple, but you need a lot of supporting functions are required to achieve the main process. So what I'm trying to tell is, how is it related to process industry? Actual process may not be very complicated. Okay, but for any process, there will be many equipment and instrument which are needed for the supporting role. So a simple activity like tea making, it has lot of functions, lot of supporting items which we don't see. When somebody says make a tea, you just see that you have to boil water and put some tea and then you make the tea. But then you see a lot of peripherals are required. Okay, so now I will put this tea making example as an example today to bring you on the speed without getting you complicated with any other process like industrial processes. The intention is to get you with the simplest system and focus on the engineering aspect of it And just be aware, what I'm trying to do is a hypothetical case. There is no such requirement in the industry. So be clear, this I am taking this an example so that you don't get confused with the actual process in the process, but focus on the engineering part of it. So skill. So if you have a tea making dish, how many teas can you make? Maybe you can make 2 cups, 3 cups, 4 cups at the maximum. But if you want more, if I have to make more, what can I do? Any answers? You can put your answers. Be free. I want answers. Then only I will be able to, because I need to know whether you are understanding or not. Any answers? If I have to make more cups, like let me say I want 10 cups.
Increase the size of the utensil.
Yes, perfect. You have to make a bigger vessel. Yes, somebody has answered bigger vessel. Okay, so you have to increase. But if you need continuous supplies, let us say for hypothetical case that a client comes and say, I want 10,000 liters of tea every day. Okay, 10,000 liters means it's a continuous supply. I cannot do batch process. So these are called batch processes. You are doing one dish you take, you put water. So these are batch processes. Okay, so if you have to do it more numbers, then you need to do a continuous process plant is required. Okay, so basically we can design a process. So did we go? Okay. So we can take water in, then we can do like store it in a water tank. Okay, so let me go to the next slide. Maybe that is better. Okay, so we normally will do we have to fill water in the jug. So this, when I am doing in a process industry, I cannot do this on a single continuous process. So what I do, I take water in a tank. This is basically my inventory, wherever I stored water. Then use a pump to pump it. Okay, and then we need to heat it. So for heating, we use a water heater. So what happens? The water in the tank will be pumped through a pump, and then I will need a water controller, because I need to control the flow of water which is flowing through this one. And then instead of heating, I use a water heater. So you have a heat exchanger item called heat exchanger. Then what I do is I need to infuse the tea powder into the water. So here again, when I do design, we will see various options. There can be multiple ways we can do this. So I will basically need a vessel filled with tea powder and pass hot water through that so that it gets infused. But why do I need to? Because one will be under filling when the other is getting used. Because this tea powder eventually will get used up. So I need to refill it. So what I will do is I will keep 2 vessels so that when one vessel is in operation, the other vessel I can use it for refilling it. So once I have the tea infused, then I will do the straining and store it in black tea storage, which is basically what we do in the batch process like this. Okay, and then once you have the black tea storage, and then different client will have different requirements. They may need more milk, they want without milk, with sugar. So you can have control there. So you take black tea, again pump it. Okay, and then you take milk from storage. This can be a refrigerated storage. Okay, and then you pump it. So you pump this, basically this pump is equivalent to pouring milk into the hot tea. And then you take it and then put it in a tea dispenser, because sugar needs mixing. So what we use, you use an agitator equipment called agitator. Okay. And then we put in sugar inside. Okay, so basically it's like a sugar storage. and then you mix it. And when you are making the tea, you do the mixing with spoon. So instead of spoon in industry, we will have agitators. And once it is well agitated, you get the required quality, then you can send it to your customer, product tea. So you get the product tea outside the. So this basically, I'm trying to explain a simple process like tea making. If I have to make it a process, how it will be. Now we'll see how it is related, because now you know that for pouring water into a vessel, I am using pump. So pump basically helps to transport liquid from one equipment to another. And then we'll have different types of heater to heat the process fluid to the required temperature. And then we'll have different types of vessels with solid desiccants. So these are variously used for various purposes like dryers and catalyst reactions. You'll have solid beds available in industry. So you don't have anything called infuser actually in industry, but you'll have solid beds which is used for catalyst reactions or air drying. Or there are like even PSAs, you know, have you heard PSAs? Anybody heard PSAs? This is basically used for pressure swing absorption systems for making nitrogen from air or oxygen from air. You have typical adsorbents which absorbs only the oxygen, it absorbs and releases nitrogen. Okay, so those type of equipments you'll find it here. And then you have basically vessels which is used for storing, and then you have pumps, and you say you have agitators. So these are basically the workflow. So just keep it in the context. When you go to each equipments, then you will come to know what we are talking about. So this is, I'm just setting the context here. So I will be talking about this process and then introduce you to various equipments. So introduction, what is process industry? Production processes are generally continuous. Sometimes batch processes can be present. Example, a refinery uses crude oil as input, converts it into various useful components such as gasoline. I think this we explained already. Okay, common process industries include oil and gas processing units, refineries, fertilizers, food beverages, chemicals, pharmaceuticals. So basically there are different types of process industry available. So what I am trying to explain with the tea example, in reality, if you go to industry, you may find it in oil and gas processing industry or refinery, fertilizers, food. So any industry, anything which has a continuous process will have be termed as a process industry. And what are the typical equipments used? There are various type of equipment. We just saw a few equipments there. So like pumps, we use compressors, we use reactors, distillation columns, we use tanks, pipes, valves, measuring instruments, control systems, electrical systems. In fact, each one is an item for a presentation. So I'll be only telling broadly what it is doing with a limited time to get you how the whole process works together and how the engineering coordinates with each other. That will be the focus for today's presentation. Okay, so the whatever process we have shown, so basically the initial screen in an actual process industry, we call it a process simulation. So basically we design the process. We mean the basic flow scheme is decided while we do this simulation. This is like a simulation exercise in which we will fix so many parameters like operating parameters. Okay, at what pressure we should be sending this, what should be the temperature. Okay, so many parameters will be decided. In reality, when we make tea, our pressure, we don't decide the pressure because pressure is given to us because it has to be atmospheric pressure, because we are heating the pressure in the tea in atmospheric pressure. But when I'm designing a process industry, I have the flexibility to play around with the pressure. I can do it at a higher pressure, maybe. I can do it at a lower pressure. Okay, and then with even temperature, I can decide. If I want more temperature, in reality, when you do tea making, you are fixed with 100 degrees Celsius because water boils at 100 degrees Celsius. So you are not doing any temperature control, because temperature is controlled by the physical property of water itself. Okay, but when I am doing a water heater, I have the choice to decide the temperature. I may have some control schemes in place to control the temperature. So which is possible when I am doing. So the point is, I will decide the operating pressure and operating temperature at various points. Okay, once I decide the operating pressure and temperature, then I will decide the design temperature and design conditions for these vessels. So any equipment in process industry should have a design conditions. Basically, what should be the design temperature and design pressure. So once we fix it, then we know also we'll fix what is the flows. What is the amount of flow required? If 10,000 liter is the product what I require, then for each segment what should be how much water should be flowing? How much tea should be flowing? Will it be continuously flowing? So, and what can be the maximum capacity required? So those type of decisions are required at the early stage of the engineering. So once I know the flow, once I know pressure, once I know temperature, then we fix the design conditions, then we can size the equipments. Once we size the equipments, we convert this process flow diagram to something called P&AD. Okay, so what I'm showing in this slide is a very, very preliminary P&AD, because when you see an actual P&AD, you will have much more walls around it, and it will be too difficult to understand. That's the reason I did not present anything complicated here. Because, for example, if you take a vessel, it will have drain valves will be there, vent valves will be there, there will be a maintenance, there will be a manhole. So many informations will be there around this vessel itself. Okay, so each and every point will have much more information required, because there will be practical requirements for achieving many things. You may need a flushing line for cleaning it. You may need a drain line. You may need a vent line. So there are so many requirements which comes in a P&AD. But here what I try to do is to give a brief how the P&AD will look. Basically, it will show all the equipments. It will show the isolation valves. Like, for example, somebody needs to take pump on maintenance. I can close these valves and take the pump on maintenance. There should be a control valve. In a P&AD, actually, you will find some instruments also. What are the temperature I am measuring, pressure I am measuring. Okay. And how the heating fluid is controlled. Okay. So there are so many items will be covered. But here what I'm saying is the process flow diagram which is given to you, that is shown in the previous slide, is now converted to a preliminary P&AD. We show water tank, water pump is pumping to water heater, and you have two tea infusers, and this can be isolated by valves. So when the tea powder inside is used up, then I can close this, and then I can use this for making the tea. And then you need a tea strainer, because any powder getting carried over need to be stored before going to the black tea storage. And then we have the black tea pumps, milk pumps. You can have the control here, and then you do the dispenser, and then you send it. And here you can add the sugar as required. So this is called P&AD, and at the stage of P&AD itself, there will be various informations like what is the temperature, and what is the size of the lines, what is the size of the vessels, what are the design conditions. Those things are decided. Okay, so what we'll do is we'll just go through a brief of all the equipments we are handling. We'll give you an overview of the equipments. So, like for example, exchanger. We talked about exchanger. Exchanger can be many different types. It's generally used for heating or cooling. Okay, so you will have some exchanger will have a steam coming in, condensate going out. You will have some process fluid, and then you have vapor going in. So it's basically one stream get cooled, and another stream will get heated up. So this is a typical arrangement for a shell and tube exchanger. Like you have a shell will be there, and within the shell there will be tubes, and on the shell side, one of the fluid will be passing, and on the tube side, like the blue color is passing through the tube side. So this one can be hot fluid and another can be cold fluid. and because we have multiple tubes here, there will be a lot of surface area, and due to surface area, the heat transfer will happen. So there are different types of heat exchangers available, like air coolers, plate exchangers, double pipe. And then comes pressure vessels. So this is a typical pressure vessel. You'll have a manhole here. Okay, various nozzles will be there. On the top, you can find some nozzles. Okay, this can be normally used for storages. Like in our tea case, we are storing it for storing the tea. This can be made with the different materials depending on the service. Like it can be stainless steel. If it is food industry, it may be stainless steel. Okay, if it is a corrosive, then it can be some typical alloy materials to avoid corrosions. So, but then any material, generally it is made from plate. Plate is rolled into the circular shape, and then once it is rolled, then the end distance are welded. So you can see the weld joints here, and there will be one seam joint also. So it can be one or more plates will be joined to make this vessel. So pressure vessels are very commonly used. It can be used for storage. It can be used for separation of gas and liquid. Okay, desiccant bed or catalyst bed. Like the way, basically I told about tea infusing. You don't have anything like tea infusing in actual process industry. But you have similar things like desiccant beds are there. Like you have a vessel filled with desiccants, like a solid bed will be there. It will be like small granules of solid, put it in as a bed in the vessel, and then that will be used for removing some particles from the process streams, like for or initiating a reaction. Like you can have a catalyst bed, also can be a solid bed, or you can have air dryers. Typical usage is air dryers, like we have activated alumina is used to dry the air. Is there any questions from you people? You are with me, or is it going overboard?
So if you have any queries, you can ask. The speaker wanted to be a very interactive session. That's why we are limited the participants also. So all of you, please, any questions or any doubts, just raise it either by chat box or by just unmuting your mic.
You can unmute and ask questions. It can be any foolish question, no problem. Let me ask a question. Okay, so just to break the ice, why do we use pressure cooker? Anybody knows? Because we are in kitchen today, so we'll talk about kitchen more. Why don't we use normal vessel? Why do we use pressure cooker? Can anyone give a scientific explanation why we use pressure
to increase the boiling pressure, boiling point, increase the boiling point due to increase in pressure.
Yes. So that is a way let students give.
Okay, let them speak.
Fuel efficiency. Fuel efficiency, yes, it is indirectly correct. Cook quickly, yes, correct. But actual reason why Rajiv sir has given the hint already. Higher boiling point, yes, Rajiv sir has said. But okay, to increase pressure and decrease. Okay. Okay, so pressure increment. Good. Some answers are correct. Okay. So higher pressure, basically the yes, good. So higher pressure basically creates the boiling point of the water will change when you do the higher pressure. Okay, basically this is the steam table. If you look at the steam table, at a lower pressure, the water boils at lower temperature, and when you get a higher temperature, then you get the food will cook faster. Okay, so we'll come back. Okay, good. So coming back to the slide again. So these are the desiccant bed. And this is a typical agitator. You can have agitator in a tank. So it is driven by motor and gearboxes. So what we showed, the example of spoon stirring, that is enabled in an industry by a stirrer. And this is a pump. Anybody knows what is the dynamic and positive displacement pumps? You're seeing something here. Any guess what is this? Okay, so these are basically dynamic type of pumps. There are two types of pumps. Yes, true, pump. Okay. So these are multi-stage pumps. Both are dynamic type of pumps. Basically, it is creating the velocity. And once you create the velocity, it pumps, it creates that velocity will be converted to pressure energy and it will be pumped. Okay. And there are positive displacement type of pumps also, which will be using like to and fro piston motion or a gear pump, which will be used for pumping the fluid. Both types are used in industry, but most common is the centrifugal types. So if you need higher pressure, you need to have multiple stages. And this on the right hand side, what you are seeing is the multi-stage centrifugal pump. And then after this, all this equipment, you need to connect this with each other. So for that, you need pipes and you need pipe fittings. So one of the major area for mechanical engineers is on piping. So piping is a huge subject in itself in process industry. There are people specializing in piping only. So piping basically will have pipes, bends, tees, walls. Okay, so you see these are the flanges. Okay, we used in this one. This is an orifice put in on a pipe, which will be installed in the pipe. So in between you have a orifice plate will be there. Anybody knows what is an orifice? What's an orifice used for? Any guesses? What's an orifice used for? Increase velocity. Not really. Finding discharge rate is correct. Finding discharge rate is correct. And there is one more measurement flow rate. Correct. Okay, very good. So it is good for use for measuring flow rates. So you measure the upstream and downstream pressure, and then upstream and downstream pressure gives an indication of measurement of flow rate. And also it is used for restricting the flow. Okay, so increase flow rate velocity, that is correct. Suraj Dev has answered increase velocity. That is in fact correct because velocity will increase, but the intention normally is to reduce the pressure and reduce the flow. But the effect of orifice will increase the velocity. That is true.
Rasuk, it is also called restriction point sometimes.
Yes, it is called. Yes, correct. It is called a restriction orifice or measurement orifice.
Okay.
Yeah.
Thank you.
Yeah, thank you. Okay, typical PNDD, already given the typical PNDD there. This is also another example of a typical PNDD in process industry. So this is more serious. You will have the reason why I showed this is you have instruments various instruments are also shown. Basically, like control valves are shown. There is some measurement and then some control happening. Okay, so you'll have various details coming here, and then if you see, you can see that there are drain lines here. Okay, some drain lines are given, some distance requirements are given. Okay, some places they will be giving, the sizes will be given, instruments are given. So various informations are given. Like for example, here you see this is the drain line. Okay, so this is not part of the original process, but these are required to support the activity. This is what I meant by saying the supporting functions. So actual process may be taking some fluid from somewhere and then processing it and sending it. But in a PNDD, you will see many lines, because it does many lines does the supporting activity. And that is why you see any process plan documents, you'll initially find it very overwhelming. So the idea for me to tell here is, don't have to get overwhelmed. Actual process may be very simple. Yeah, I think this is the same thing. Okay, and one of the main thing in a process industry, once you design the process, you need to make sure that it works the way it is intended. Because I have fixed the operating pressure, I have fixed the operating temperature, but how to make that, ensure that it works? So for that, we need to measure many parameters, and we have to ensure that those parameters are controlled. So we'll have control valves in the system. So if you see here in this diagram, we have a level control. It can control using the control valve. In the pump, I will have a flow control. Okay, again, flow control is based on the level control. So if the level is increasing, then I will increase the flow set point. And this vessel, I need to control the pressure. So I have a pressure control here. And then you'll have some shutdown valves also in case of emergency to shut it down. So this is basically a process control. So in a PNDD, if you see, you'll see a lot of process control in details indicated in a PNDD. Okay, so control valve, like for example, when you are doing our tea making, you have a gas regulator. So equivalent to the gas regulator is the control valve in process industry. This is what a control valve look like. So if you see, this is the pipe, you have the valve here, and valves are controlled by actuator. Again, now comes the actuator. So how the actuator will be operated? Any guesses how the actuator can be operated? Anybody knows how an actuator can operate?
You mean electric? Electric,
yes, electric actuator also is there, but this one is not electrical.
okay.
Any guesses?
Pneumatic actuator.
Pneumatic?
Yes, pneumatic, yes. These are pneumatic. And now again, the question comes, when you have pneumatic actuators, you need an independent system in the process plant to supply pneumatic air. So this is what the supporting functions keep increasing. When you have, even though the process itself may be simple, the supporting functions will keep increasing. So you need a separate system to supply instrument air, and then you have the instruments to control the supply of instrument air to these actuated valves to maintain it at the required valve opening position. So this is what typical control scheme will be. So we'll measure the flow, and then there will be a controller, which is basically a DCS controllers nowadays. And then there will be a signal coming, and from using the signal, the control valve will be operated. So whether to keep it 30%, 20%, whatever opening is required, that can be maintained here. And then we have relief valves. So in any industry, we have already fixed the operating pressure, and based on that, we'll be fixing the design pressure of the system. So at any point, we'll keep all the control system in place to ensure that design pressure is never exceeded. But suppose control fails. So I need one more layer of protection in the system, that the system will not get over-pressurized and result in an explosion. So I will provide safety relief valves. Safety relief valves are basically, you'll have a spring-loaded system in which spring will be keeping closed the valve. So anytime the pressure increases, the pressure will overcome the spring force, and it will open and it will get released. So the simple example what we see in everyday life is a pressure cooker. So as we said, the pressure cooker example, why we are maintaining the temperature boiling point, we are increasing by increasing the pressure. So we are maintaining the pressure by keeping a weight loaded relief valve on the top of the lid. So the difference is, in an industry, mostly you will find spring loaded relief valves because the force requirement is huge. It cannot be achieved by a weight. But in our home situation, our weight is enough to maintain because we are only increasing the pressure from 1 bar to 2 bar G. So that is required only. So small weight is required for adequate for achieving the purpose. So this is pressure relief valve. Okay, fire deters. So do you know this picture? This is our normal gas stove. Okay, so do you know where the air is taken? What is required for burning? Any fuel, what is required for burning? Oxygen, yes. So in this example, if you see our gas stove, I put the pictures. Do you know where the air is coming from? So you're right, the oxygen is taken from the air, but any idea where the air is coming from? Because if you see the flame starts right at the hole. So where do you get the air? Any idea? In fact, if you look at the gas stove in detail, the actual fuel jet is here. The red one, the brass one, sorry. The brass colored one is the fuel jet, and then you have a mixer pipe. This pipe is called mixer pipe, whatever you are seeing here. And these pipes, on the side, there will be some small holes here. In this pipe, there will be small holes here. So the fuel will be injected, and that through that holes, the air will be sucked in. And a good design of gas stove makes sure that fuel and air gets mixed up in this mixing pipe before it comes through the burner end. So by the time it comes here, the fuel and air would have created an adequate mixture, okay, so that it burns in a uniform blue flame which shows complete combustion. So in an industry, we achieve this by fire deters. And in industry, what happens is we have something called burner, in which if you see, there are two lines coming. One line will be the fuel line and another line will be the air line. And you have a mixing chamber here where the air and fuel will get mixed before coming out and where it will be lit. So a good fire heater design, if you see, there will be fuel and air getting mixed and then burning it through the system to ensure complete combustion of the fuel. And then after that, you provide tubes inside in which process fluid will be passing, and this heat will be transferring the heat towards the tubes where to heat the process fluids. So it is similar to our gas stove heating the bottom of the vessel. So the same purpose, but in a more for surface areas required. So you have a very large scale design that is called fire deters. These are used in process streams. Two reasons when it is used: when you have excess fuel which cannot be used anywhere, then you tend to use fire deters, or you use fire deters when you need very high temperatures. But I have seen using fire deters in places where I require very less temperature, but we had some excess fuel which we cannot do anything except flare it away. So we, instead of flaring it, we used to capture that heat, put in a fire heater, and then use it for some process heating purpose. Okay, so this was an introduction to various equipments. I tried to explain, give you an idea about what are the different equipments you come across in a process industry. And then next I will say how these things are designed. What is the general workflow, how we design these items. So I'll give 1 or 2 slides to explain how the design flow proceeds. And also you can see from your respective of your discipline, what are the different areas available in a process industry in the engineering design. Okay, I have not covered anything related to maintenance, operations and other aspects, which I showed in the first slide. Okay, but for an engineering point of view, what are the different areas a mechanical engineer or a civil engineer or any other discipline engineer can get involved? So process design. So evaluates various options and decide the configuration. So process design at the initial stage, the process, we have to evaluate different options. Like for example, in our tea making, I decided to have that tea infuser, but somebody may say, I don't need tea infuser. I will mix the tea powder along with the fluid and then strain it away. It can be a different design. Okay, that heat exchanger, instead of heat exchanger, I will say I can use fire heater. Okay, or I can say that I will not mix the sugar in the agitator. I will use something else, static mixer to do it. So the various configurations are available. Various ways we can design the same process. So those decisions are taken at the early stage of a project, and that is part of the process design. Once we do the process design, we'll decide the design conditions, that is temperature and pressure. So because once we know the design is frozen, operating pressure, operating temperatures are known, then we'll decide the design temperature is decided by the process. And then also the capacities of equipment. Here you have to make a small distinction. Capacities and design are different. When I say capacity, like if I say vessel, I need a capacity will be 1000 liters and design pressure will be 10 bar G. So that is decided by process. So process basically, if I take a vessel as an example, we tell that it should be 10 bar G design pressure and capacity should be 10,000 liter. Okay. And then once you do the capacities, process also will say any layout requirement. Sometimes we'll say some vessel has to be above the other vessel. Okay, or pipe has to be sloped. There should be no pockets in the pipe. Such requirements will be given by the process. And also various requirements will be given by process in terms through P&D diagram. We call it P&D diagram, piping and instrument diagrams, like various control requirements, measurement requirements, pipe sizes, operation requirements, layout requirements. Many requirements are given through the P&D. So once these informations are given, so the further engineering will be done by various disciplines. So piping will confirm the layout based on the process requirement. So they will fix all the vessels in the thing. Then they will carry out the piping design. So each is a subject by itself. But here you can understand that piping is you have to connect between the equipments and then according to the sizes given by the process, provide proper supports, provide proper access to the walls, because walls, if it is there, it should be accessible to the operator. So there should be pathways should be there, layout requirements should be met. So those things will be done by piping. And piping engineers are normally mechanical engineers. No, not normally, always. And in fact, I forgot to tell you, I am myself a mechanical engineer, happen to be in a process. Okay. And then you have mechanical static. They design basically all the static equipments like vessels, distillation columns, heat exchangers. All static equipments are designed by static. Sometimes they may give it to outside party, but generally all these vessel design. So if I say like process has given design pressure and capacity, that mechanical will design what should be the thickness based on the design pressure and capacity. So they will decide what is the thickness. Okay, and also the material of the vessel will be given by metallurgy. Here I have written. So metallurgy will be confirming the material. So based on the information, mechanical static will design the equipment. And once they design the equipment, they know what is the weight of the equipment. They will pass on that information as a load data to civil. Okay, so then civil can design the foundation based on the load data given by mechanical static. Similarly, mechanical rotating will specify what is the rotating equipment requirement. They will not design the rotating equipment because it's always done by the vendors. But there are various standards requirements for rotating equipment. Okay, so those are specified by mechanical rotating, and then they will coordinate with vendor for delivery. Similarly, health and safety, this is very important because when we are in a process industry, we are playing with very hazardous fluids. So anything wrong in the system, it can create big accidents. And there are a lot of accidents which had happened. We are lesson learned from those accidents. So there are design practices to be followed. There are statutory requirements. So health and safety will ensure that all disciplines, whatever design is being conducted, they are being conducted in a safe manner, and there is no absolutely very little, all chances of accidents are minimized. We call it alarm as low as reasonably possible. So that will be done, and then they do the hazardous area classifications. They will conduct various safety studies. They will do the fire and gas mapping, and in fact, really, if the fire actually happens, then how we can mitigate it. So all those things are handled by health and safety. Okay, and then civil and structural. Once they get the civil, the layout, foundation inputs, load data from piping, mechanical, static, and rotating. They will design the foundation. They will design the structurals, platform, pipe racks in the process units. Instrumentation control specifies all instruments and controls, control system implementation, DCS systems, all done by instrumentation control. And then there is metallurgy. Metallurgy can be real metallurgy, but I have seen even metallurgy people coming from mechanical. Okay, so they confirm the metallurgy of equipment and piping based on the process fluid, because the corrosion is a big problem in the industry, and we have to ensure that the equipment designed will achieve the design life. Normally it is 20 years. So 20 years life is achieved. So that will be confirmed by the metallurgy. And then they will, so sometimes you cannot have very high quality metallurgy because of the cost. So then you have to decide on material, and then you have to apply some corrosion control measures like corrosion inhibitor injection or cathodic protection. So there are various corrosion control measures to be used with the commonly used materials. And then we have electrical system. Electrical will design the electrical systems because there will be a lot of drives, transformers required, various high capacity motors will require different voltage levels. So all those electrical system design will be done by electrical. And then nowadays the telecom is a big area for any process industry. We have public address systems. We have even the distributed control system as Ethernet network will be there. So all these things has to be interlinked. We have closed circuit TV will be there. Public access system will be there. The access control will be there. So all these things are handled by the telecom. So this is in brief what are the different disciplines and different types of activities done by engineering in a process industry. So thank you. And now if you have any questions, I'm there to answer.